Park. Welcome to our first of monthly debate series that were started as part of our membership drive. And tonight is going to be, we picked probably the most interesting topic for tonight, mainly because we have two experts that are going to talk about it. Global warming is real. Who caused it? And who caused it? Those liberal rascals caused it. That's what it was. Speaking for the human cause is club member Dean Warren, and opposing the human cause is Martin Stickley. We will have a 20-minute presentation by each, then a 5-minute rebuttal, followed by written questions from the audience. And we have a pad there, and if you just raise your hand, Sharon, our membership director, membership vice president, will hand them out. Let me ask, can we have a show of hands of how many guests are here tonight? Doug, you're not a guest, you're a member. We have the pencils and paper for you to do. We encourage written questions only. I think I will now introduce our debaters. Dean Warren is a World War II veteran who later was a member of the radiological safety section at the Bikini Atom Bomb Test. Raised to be a medical doctor. You know, I have this pain in my... He took physics, chemistry, and biology and calculus in college, and then changed to political philosophy. It's a good transition, Dean, in which he also did graduate work at the London School of Economics and Harvard. In his working career, he spent several years in the State Department, as well as many in the aerospace industry at home and abroad. He ended up as Director of Strategic Planning for Martin Marietta Electronics and Missile Group in Orlando. He is the author of 4 science fiction novels and 2 memoirs and runs the science program of the club. Martin Stickley received his degrees in electrical engineering from the University of Cincinnati, MIT, and Northeastern University. As a young lieutenant in the USAF, he built the Air Force's first laser. Laser research and development was a principal focus of his career that was spent with the Air Force, the Defense Advanced Research Projects Agency, DARPA, the Department of Energy, and the BDM. He worked for the government, you could tell. He later joined UCF in 1990 as a professor and associate director of the Center for Research and Education in Lasers and Optics, CREOL. He has retired 4 times, and is he going to stay retired this time, dear? Thank you. By a mutual agreement, Dean is going to start. Floor is yours.
Good morning. Good afternoon.
We're off to a good start.
Frank raised the question of who caused global warming, and I hope it's not hot air from places like this. Hello. Hello, hello. Now I've got to figure out how to start this thing here. You got to get rid of this.
Dean, that's your problem.
For we technologists, this is obviously humiliating.
Manuel, we need some technical assistance, please.
Wait a minute.
There we go.
No, he
There we
just
go.
blanked
It's just
it.
slow.
I think maybe it's just slow.
No. Here we go.
Manual, oh, here we go.
There we go.
There we go. I can do it now, I think.
Just you right here, right?
Yeah, that's me. Yeah, I'll use my mouse over here. I just did it,
Okay. Right.
I think. I just have to wait a little bit. Maybe I have to press again. We're using the club's laptop here, and so I think both Martin and I are here. Okay, Merit start. Okay. Yeah, the issue here between Martin and I is not whether there's global warming, it's whether it's caused by man, and therefore we should do something. We have the responsibility of doing something about it. Now, the role of CO2 in global warming was sort of originated back in 1896 by a scientist, Arrhenius. And for the early years of this century, it was a scientific specialty that didn't reach much publicity. However, in 1998, James Hansen, who is the PhD, who is the director and has been since '81, the director of the Goddard Institute of Space Sciences, a NASA organization, gave a testimony to the Senate where he said that the globe is warming and CO2 was responsible. Now, the Reagan administration really didn't accept that and thought that there was no warming, but it became pretty obvious. And by 2005, Mr. Bush agreed that there was global warming, but that he didn't feel that they needed to do anything about it, that nature would take its course. In 1988, at the same time Hansen made his presentation, the UN formed the Intergovernmental Panel of Climate Change, which is a international group of people that have been studying this issue for a long time, and they have issued 4 reports and are working on the 5th. So it has become fairly controversial since then, since there are a lot of people who are deniers. I might just like to make an aside that James Hansen did his work in Iowa, the University of Iowa, and he studied Venus. Venus has a temperature of 700 or 800 Fahrenheit, degrees Fahrenheit, and it's made of the same geology as the Earth. His conclusion and other people's conclusion was that they had a runaway greenhouse effect. They have volcanoes, a lot of volcanoes, more than the Earth has, and they produce a lot of CO2. And the temperature from the greenhouse effect soon grew over 212 degrees Fahrenheit, and all the water started boiling. And the water on Venus has all evaporated out into space. And now the atmosphere of Venus is CO2 and nitrogen, and the clouds are hydrogen, are sulfuric acid. So that sort of motivated some of these people, is the possible end date. Now, there's been a lot of argument, but the scientific community claims there's a consensus of the sciences that CO2 is responsible. There are some scientists who deny this, but the organizations of science all say that CO2 is responsible. In fact, in October of last year, very recently, the National Science Foundation coordinated a letter to the Senate which said essentially what this chart says. And it was signed by 18 major U.S. scientific organizations. That was done because there is a bill in Congress that was passed by the House but is blocked in the Senate. And it is a cap and trade bill, they call it, where they essentially get a price put on carbon, which will start restricting the emissions of carbon and carbon dioxide in this country. Some of the people who signed it are the American Association for the Advancement of Science, the American Chemical Society, the American Geophysical Union, the American Meteorological Society, the American Institute of Biological Sciences, and it goes on. Anyway, they were all signed by the presidents of those organizations. I got a copy of the letter for anybody wants to see it. Now let's get into the substance of this. I'd like to start with this chart and explain some things that are key. The black line out here at the end really starts in 1860 when actual sensors, thermometers, were being reported about what the temperature in the world is. And they have been able to make it. I mean, the scientists have worked a lot on trying to get as many data points as they have. Before this 1850, all these other lines, these are 8 different reconstructions of the possible last 2 centuries of temperatures. Before the thermometers came out, they looked at tree rings. The oldest tree ring in the world is called the bristlecone tree, and it's in California and Arizona and New Mexico and Nevada. And the oldest one that they have been able to carve open is something under 5,000 years. You can imagine, I mean, that's one data point from one area in the world. They also have drilled into the ocean and going down layers of sediment that have come out of rivers, like out of the Mississippi. And they have counted the layers. There's one other real way that I'll get to later, but I should explain this chart. The temperature anomalies, rather than putting a temperature on here, they assume a mean of the middle between 1951 and 1980. Those 30 years, and that mean was 57.2 Fahrenheit, or 14 degrees Fahrenheit. So the anomaly, the temperatures you see in this are all above or below that number, because the comparison, they try to make a comparison with a recognizable temperature that a lot of people today will recognize. And you'll see in a lot of my charts, we use the same method of these anomalies. Okay, then, and also just to show you the difficulty, this medieval warm period is called by many people the medieval North Atlantic warm period, because the only data that they can really get is from Europe and the northeast United States. And they don't have any good data from the southern hemisphere for that period. So they don't really know. Now these curves, when they're out there, they claim that they're global, but they're historic, but they don't really are any good. Well, they're doubtful. Now there is one other and better measurement, which is ice borings. They have, like in Greenland and Antarctica every year the snow drops and more snow and it becomes ice, and so you get layers of snow. And that snow then has little water droplets in it, little bubbles of air, and they can look at the snow and determine, first of all, the age by the layers, and secondly, they can turn a lot of other things. I'll talk about this in a minute, but the temperature they get largely because various isotopes, like for instance, oxygen has 3 normal isotopes. This is the atom of the oxygen element, and the heaviest one will condense first because it falls to the ground, to the thing first, and so the proportion of the heavy isotope to the other ones will indicate what the temperature was in that year, because it's all relative. So they all relative, and they have other things too, like carbon. The carbon content when in normal air, the normal air is about 80% nitrogen, and when a cosmic ray hits an atom of nitrogen, it changes the nitrogen to carbon. It adds a proton. So and then it becomes carbon-14, which is a different. Carbon-12 is a normal. So you look at the carbon in there, and after, when the plant dies and becomes wood, or just becomes carbon in the ground, the proportion of carbon-14 says when the plant died. So you can figure out the date from that. Now this chart, oh, by the way, I should say, Vostok is a Russian scientific expedition in Antarctica that did the first big ice borings. The second was the European, just make sure I get that right. Excuse me, this is the second is the European Project for Ice Coring in Antarctica. And it's 560 kilometers from Vostok, and it went down 3,180 meters into the ice in Antarctica, which was essentially 800,000 years before the present. So they have borings, and each of these Epica dome lines that are up here are from different, when they go down in sections, and then they put another drill, they draw out a core, and then they go down even further. So they're different boring cores from the same hole down in Antarctica. Now, this shows, I think, a lot of people think that our warming is cyclical, natural cyclical. And there are cycles. That's what this shows. Now, the scientists think that the cycles are due to orbital changes. There are essentially 3 cycles, and the 100,000-year cycle is the dominant one that shows in this chart. And when the orbits changes, when the sun, the Earth goes around the sun, it varies between a ellipse or just a circle. And depending on what that orbit is, you get varying degrees of sun hitting the Earth. And that's what these cycles show. And when the Earth is pointing away from the sun, more away from the sun, you get more cold. And when it starts to gradually get together, you get more warmth. And when it starts getting more warm, the ocean starts exuding CO2, Because at warm, it boils off. You know, it doesn't boil, but it comes off. And so in the old days, the CO2 sometimes precedes the temperature change. So anyway, this is another way of looking at it with the ice. And by the way, the ice cores show no medieval warming period back in the Middle Ages. You know, and that's more of a, well, in the Antarctica, it's obviously in the southern hemisphere. Also, I put down here what the current CO2 level is, which is way above the historic. You can see that the historic CO2 level is just a little bit above the, well, it's about 300 parts per million. Today, it's damn near 400 parts per million. This is the most recent, this is using instruments, scientific instruments, that's telling us what the temperature has been, and made up by NASA Goddard Institute of Space Sciences, which is the Jim Hansen organization. Now, the World Meteorological Organization, which is made up of a Congress of 80-some nation meteorological societies, has declared that 2000 and 2009 was the hottest decade on record, with 8 of the hottest 10 years having occurred since 2000. 2009, the UK Met Office says, will end up as one of the hottest years since 1850, and they predict that with a moderate El Nino, 2010 will likely break the record. Now, that's, a lot of people will doubt that, having gone through the cold recently. Now, what's the justification of saying that the CO2 causes global warming? CO2, when the sun hits the Earth, a lot of it's reflected back, but it's reflected back as longer infrared radiation. It comes down as photons, you know, which is light rays, and it's converted into a different frequency and becomes infrared radiation. Certain gases also absorb and re-radiate infrared. In other words, when when it hits the CO2, some of it's absorbed, but some of it is re-radiated down to the ground. So it bounces down to the ground. And this is what the blanket of warming is. Now, these gases are 3-atom gases. CO2 has 3 atoms, carbon and 2 oxygen. And when they're 3 of them, if you guys know much about particle physics, individual atoms have a continual vibration. It's the part of the quantum theory that they have a continual movement. When there's 3 of them together, they vibrate, 3 or more of them together, they vibrate in infrared frequencies. Below that, they don't. So the nitrogen and oxygen, which is usually a 2-element gas, it's N2 or O2, that doesn't produce it, but CO2 does. CH4, which is methane, does. Nitrous oxide, which is NO2, does. So these greenhouse gases will take the sun that's bouncing off the Earth and force it back down as infrared and heat up the place. And you ask about clouds. Clouds both reflect back some heat, but they also reflect back a lot of sun. So they protect the Earth, and they do more of that than they do warm us. You know, clouds will keep in the heat at night, but they don't in the daytime. They reflect off the sun. So anyway, then I've got these. I've got what? Oh boy, okay. That's 20 minutes? Well, I gotta go then. Here's a chart which shows how the gray line up at the top where it says model is a modeled for the last 90 years of what the warming should be, and the black line is the observed number. So the models come close, and it shows you the different components of the greenhouse gases, the warming of, there's greenhouse gases, there's sun, there's ozone, and then there's some reflectance. This just shows you how photosynthesis works and the ocean absorbs and breathes out, and how small it is. If you see the man added is only 8 billion metric tons out of the 230 practically that were involved. It's small stuff. There's lots of evidence that there's global warming, and you guys read in the paper all the time. Also, we're going to grow, and when we grow, we are burning more energy. So as years go ahead, we're going to be producing more CO2. It's a real problem, and even with a lot of efficiencies, which I have on this chart, you're still going to grow to probably another 2.5 degrees centigrade. So, and there's tipping points. I'm going to not talk about that, but there are a lot of projections, and I'm skipping through a bunch because I'm obviously short of time. But there's a lot of tipping points. There's the methane that's under in the ocean. There's the methane that is in the permafrost. And here's another scenario. Now here are a bunch of projections of where it's going to go, and this is something that that the IPCC has a most favored one, which is probably out here between 3 and 4. But who knows? You have something called sensitivity, which is the amount of radiative forcing that's being done by some CO2 somewhere, and how it affects the environment, because there's a lot of different things. Now, this, for instance, the CC is a Center for Climatic Systems. It's Japanese. CCCMA is Canadian. The next one, CSIRO, is Australian. Then the Hadley Center is UK. The GFDL is the U.S. National Oceanic and Atmospheric. MPIM is Max Planck Institute in Germany. And then the last one is a non-governmental institute founded by the National Science Foundation.
Dean, can you wrap it up?
Okay, here's the sensitivity. You guys say you haven't feel the warming. Well, different places we're going to feel it differently. Here's the water runoff, the effect change in runoff, and you can see that the dark is going to fall off, and the southwest United States is going to have a drought, and we're going to be about the same. There's national security implications. There's a lot of people going to be affected, and this is my last chart for this part, and it just says that there is some good news that people are trying to build wind farms to stop coal utility plants, and China is trying. And I'm sorry I overran.
Thank you, Dean. Martin?
Okay, thank you, Dean. And Frank? Well, I represent the other side of the coin, that it is not CO2, but in fact it's nature which is causing any changes that you see. I list here the authors of the peer-reviewed published works that form the basis of this presentation. This, of course, my charts are not my work. I have found these sources of pertinent information, and these people are the authors of the works. The debate topic really is, as Frank said, global warming and cooling is real, and what's the cause? I point out the bottom here. Dean made the common error of saying that because global warming, he's confusing global warming with the cause. He gave you many examples, even his last slides, of what's going to happen if it warms. That has nothing to do with the cause. That's basically an irrelevant argument. And that's at the heart of much of the confusion of people about global warming. The issue is, what is the cause? And it really gets down to, is it the greenhouse gases or is it something else? Principal sources of warming listed here: indirect heating effects of the sun. I say indirect because we know what the sun's rays are, but there are mechanisms which are not visible to your eye, having to do with sunspots which affect it. The other major thing is energy change between the oceans and the atmosphere, and then greenhouse gases, which we've all heard about. So these are the principal sources of warming. So for this debate, my strategy here is to prove that man-made CO2 and other greenhouse gases are not causing significant warming by applying the following logic. Correlation does not prove causality, and I'll show you examples of correlation. But non-correlation proves non-causality. That is, I'll show that temperature and CO2 are largely uncorrelated, which means that increasing CO2 is not causing the temperature rises. This is an important logical point. This is how you look at and decide about some of these effects. When I say correlation does not prove causality, I can show you relationships between temperature and other factors on the Earth. It doesn't prove that it's these other processes, but it's consistent with it. But on the other hand, if there's no connection, if there's no correlation between CO2 and temperature, this proves that it's not being caused by CO2. So I'm going to cover some background observations of past natural occurrences, comparisons of temperature and CO2, and the conclusions about CO2. And then we'll have a wrap-up session, which I will talk about natural sources of heating and cooling. I'll respond to Dean's comments, and then overall conclusions. Okay, here's a global warming update. Arctic Ocean is warming up. Icebergs are growing scarcer, and in some places the seals are finding the water too hot. Reports from fishermen and hunters all see a radical change in climate conditions and hitherto unheard of temperatures. Scarcely any ice has been met with as far north as 81 degrees. Soundings to a depth of 3,100 meters showed Gulf Stream still very warm. Great masses of ice have been replaced by moraines of earth and stones. Many points of well-known glaciers have entirely disappeared. Now, does that sound familiar? How about that? This was published in the Washington Post on November 2nd, 1922. So there was ice disappearing up there. Ships and boats could go across North America. And there wasn't much CO2 in 1922, okay? So this is an example of just the normal fluctuations that the planet goes through. Global warming and cooling happens and is really nothing new. The jagged blue line here you see, this is temperature, first of all, this way. Temperature from 20 to 25 degrees centigrade. This is a year. Here we are at 2000. And this covers then 3,000 years. This is data from the Sargasso Sea. This is the sea in the Atlantic, 2 million square miles Temperature was deduced from organisms and sediment in the bottom of this, and you can see the pattern of temperature. This is the Little Ice Age. This is the medieval warming period and other oscillations. There's a 3,000-year averages here. And you can see that they figured what was the warming since 1975. This line ended in 1975, and they've added the 1/4 degree C temperature to basically get back to this point. It's right about where the average is. But this shows you that global warming happens, all right? And it goes, it's a very naturally driven cycle. Now, there are various proxies for it. Dean mentioned some of the proxies. This is an interesting proxy. I think you'll enjoy this. This is positive proofs of global warming. And this shows that it's cold back then, and you can see it must be quite warm now. Now, you would think if we developed serious concerns about the temperature of the Earth, we'd sort out what it was. But this wasn't done. This has not been done for the planet. It is just an assertion that CO2 causes it. There is no smoking gun that Dean showed you that showed that CO2 is causing it. So it's just simply an assertion. I started studying this 3 years ago, and I read and read and read, and I could never find the next reason. I could never find the smoking gun. I finally concluded, well, there isn't any. And certainly something must be going on. Something else is going on. But that's beside the point. I'm going to get into a few charts here that illustrate what's going on in nature over the years. This one is global sea level, measured by surface gauges between 1807 and 1902. Basically, we're plotting sea level here, sea level in inches. It's going up. These are years, 1800 to 2000. And what's shown along the bottom is the use of hydrocarbons. Whoops. Oh, that's good. Okay. Okay, so this is world hydrocarbon use here. Arctic air. Wait a minute. Let me switch charts. There we go. There we go. I leaned on the computer. You can't do that. So what's being plotted here is the sea level averages, and you can see back in this period, 1850, water started rising. Notice it's well before any of this occurred, and water has you see this jagged line. It has continued to increase, and sure enough, there's no change in the slope. If all this use of hydrocarbons were influencing the temperature, you would think that the sea level would be rising faster, but it doesn't. So the slope is constant across this. That's really showing that the CO2 is not influencing that. One can see the same thing for glaciers. This is what we're plotting here is an average glacier length, and it's an average of about 169 glaciers from 1700 to 2000 over this period. The curves look quite a bit the same. Here, glacier shortening trends. They start to short or start to melt, let's say, at the end of the ice age, which is here, and it starts increasing. And note that even though hydrocarbon use is going up all the time, it doesn't really affect the slope. And so that says again that they really are not influencing the temperature there, which may be causing the glaciers to melt. This is a similar plot of Arctic surface temperatures, plotted this way versus time. Here's the world hydrocarbon use, and this is the temperature. Dean showed our curves is similar to that. The blue is the Arctic temperature. It's got this dramatic drop in it and goes on up. It's not correlated with this. It does turn out, and I'll show this curve later, that solar activity does, in fact. That's the solar activity. I'll talk more about that later. But temperature correlates with the sun, but the hydrocarbon use does not. This is rising, but this is a huge dip in it. Just at the time, there was substantial use and production of hydrocarbons. In the past decade, I think some of you say, well, that's old stuff. What's going on now? In the past decade, the temperature correlation with CO2 is so poor as to be negative. This is CO2 as measured at Mauna Loa in Hawaii. And this is the data from, first of all, satellites. The satellite data is from University of Alabama in Huntsville. And this is data from the Hadley Institute in England, the same one that wrote all the bad emails. But even then, they couldn't hide that. It's dropping. This is, of course, what they didn't want to show anybody, was the fact that the temperature was dropping. So the temperatures are dropping by these two measurements, and the CO2 is rising. That's a negative correlation, so that says it's even worse than non-correlated. I'm missing a chart. Maybe I can find it now. Well, that's too bad. I'll go back to that. All right. I'm missing a chart, but let me tell you what it is. This is a plot of 10,000 years of ice core data. Dean explained ice cores nicely, and this is in fact temperature data. This is in degrees centigrade. We are here at 2,000. Note the temperature here. It's about at the average. What the chart that's missing here is one of carbon dioxide. And the carbon dioxide, that plot is from the IPCC. And I really regret I haven't got it. I may find it later. But it shows that a tremendous, let's say, a rise in carbon dioxide here, which is what we kind of know is happening. But then it's virtually flat. It's very flat across this. Now, if CO2 is causing temperature increases, you would expect the CO2 to have the same kind of structure, but it doesn't. By the IPCC's own admission, it's constant. So how can you get this significant temperature variations going on if CO2 is causing temperature rises? Other things you learn from this, at least from this data, is that it's been considerably hotter in the past. This is the globe. This is a medieval warming, which Dean says doesn't exist in the ice cores. This comes from the NOAA. This is NOAA data. It shows you that the temperature was hotter here. This is the medieval warming period. This is a little ice age. We've recovered from that. And so the temperature has been hotter all the time. If CO2 is higher now, then it should be a lot hotter than it is. But the CO2, this was in the time when CO2 was around 280 or 300 ppm. CO2 is now 380. If CO2 is causing warming, we should be a lot warmer, but in fact we're cooler. So there is no correlation between CO2 and temperature. Dean talked also about ice cores. This is data which shows it's an expanded view. They've got some higher resolution charts. This is years, 100,000, 150,000 years ago. And so time is proceeding this way. Temperature started going up. The temperature, blue is temperature, orange is CO2. And you can see that the temperature rises and CO2 follows it. This is on the average about 800 years. Temperature drops, CO2 follows it. You can see how those cross. So there's a time delay between the carbon dioxide and the temperature. If CO2 was causing temperature to rise, you wouldn't have this. The CO2 would not lag behind the temperature changes. But that's what it's doing here. So if CO2 is causing the heating, CO2 would not lag behind the temperature change. Yet another example. So what have we learned from these charts? Well, if the rates of sea level rise and glacier melting aren't affected by fossil fuel use, then additional CO2 must not be causing the Earth to heat significantly. That's that statement. If temperature changes and CO2 remains constant, they must not be linked together. It means they're not correlated. If the temperature goes up and the CO2 just doesn't move at all, then they certainly aren't correlated. If temperature rises and the CO2 rise lags the temperature rise, CO2 must not be causing the temperature rise. They'd have to be in sync if they were causing it. It's been hotter in the past than it is now, and the CO2 has been lower. As I said, it's now 280. It was 280. It's now 385. If the greenhouse gas heating was significant, it should be a lot hotter than it is now, since the CO2 is so much higher. But instead, it's going the other way. It's cooler. And the final point is that our current temperature lies well within the range of the normal variation of the Earth's temperature, which I showed from that chart. So the temperature is not out of range at all. We conclude that there's almost no correlation between temperature and greenhouse gases, and that this non-correlation proves that a changing temperature is not caused by changing greenhouse gases. Okay, Dean?
Very good. Thank you. That was a good time to write your questions.
Yeah. Well, it's obvious that Martin and I disagree on numbers. Let me get my, yeah. Oh, I was on the wrong one, you're right. If you can see here, this is my version of one of his, or several of his charts, and I show a plateau here between 1940 and 1980. And as I read off, the World Meteorological Society says that the last 10 years have been the warmest in decades, and that and that's what this chart shows, except it doesn't go out to 2010. And he was saying that we have gotten cooler. Now, this last week, we have gotten cooler, but only in the northern hemisphere. The southern hemisphere, like Australia and New Zealand, have gotten warmer. Yeah, and it's winter time now. That's why it's cooler. I mean, and there is natural variability. There's one scary thing about this cold snap we have. That the east coast of the United States and Europe is warmed by the Gulf Stream, which brings up hot water from the tropics and heats up the whole the coast. And if cold water comes out of the Greenland ice sheet by melting in Antarctica and comes down, it'll slow down that and maybe stop that chain of water, warm water being brought up, and we'll be cold again. So global warming can bring freezing temperatures. Now, they have measured the water up in northern areas. I have a quote here about that, and they find that the warming there is cooling on this Gulf Stream. Now, whether that will create a tipping point yet, we don't know. But in any event, and then his talk about the Arctic and the Arctic ice. Well, yeah, the ice is growing back, but the thing about the Arctic ice has been it's thick. It used to be feet thick, and now when it forms in the winter, it's skim ice, and that's undoubtedly what's forming up there. And you know, the Russians and a lot of people are fighting over prospecting in the Arctic for oil because it's opening up there. So all the indications are, I think, it's cooling, that it's warming. I wanted to show you that again. That's the areas in that's precipitation. No, that's temperature and precipitation. The areas in red are the ones that are going to change the most, because of course. In the northern, very farthest north, in the winter, the sun you see the sun only for maybe 4 hours at the horizon. It doesn't get a lot of sun, and therefore it's going to get colder at the top, or get hotter in the summer. So, and then the water, you can see the amount of water. You know, China is going to be about the same in water. Morocco is going to be minus 40 inches of water. Now, he talks about the solar cycle. The red is the radiance of the sun. It hits the upper atmosphere at the top and is picked up by satellites. And we can only pick it up for the last 30 some years because we didn't have satellites collecting that kind of data. But the red shows that essentially the sun effect on the Earth has stayed about the same. Now, in the last 20 years, there's been a lot of more sunspots, but sunspots are surrounded by, I've forgotten what they call them, but they get in the sun when there's a dark sunspot, the surrounding area gets hotter. And so you don't really change the area, the radiance. And you get maybe solar flares more, or you get less in this period. And that should, if anything, cause cooling. Another thing of the opposing, another theory of the opposers is that cosmic rays hit the clouds and hit the atmosphere and hit molecules of gas like oxygen and create even very small particles called muons. And they then are a thing that will condense water on, and you get more clouds. And therefore, the more cosmic rays you have, the more clouds, and therefore the cooler it will be, the more reflecting you'll have.
Can you wrap it up, Dean?
Okay, so this chart just shows that there's been historically since the 50s, there's been no increase in or decrease in cosmic rays, and while the temperatures have been going up. I guess I stop.
Thank you, Dean. Martin?
I got to get out of this. Okay.
Customer Experience Improvement Program. Let me get rid of that. Okay. Trying to find where I was. I think it's about here. No. Okay. Now, let me make it larger. Okay, here we go. So if the temperature changes aren't caused by greenhouse gases, what's going on? What's causing the Earth's temperature to rise and fall over the centuries? As I mentioned earlier, the principal sources seem to be circulation changes in ocean flow patterns and sunspots, along with greenhouse gases. I'm going to talk about ocean flow patterns and sunspots. The first few charts about the ocean flow patterns. It's interesting, though, the ocean holds as much heat in the first 3 meters of depth as the whole atmosphere. And so when flow patterns change, as they do, they bring warm water or cool water to the surface. And that, of course, affects, with all that heat storage, that affects the atmosphere. There are, these flow patterns change in the Pacific and the Atlantic, and they result in an increase in sea or decrease in sea surface temperature. And when they do, the air is either heated if it's an increase or cooled if it's a decrease. And the whole mechanism for this is really a current research topic. But one possibility is that what is called a Pacific decadal oscillation affects cloud coverage. Anyhow, these flow patterns are called Pacific decadal oscillations or Atlantic multi-decadal oscillations. That's because these last over 60 years. These are more like 30 years, and their periods range over this period of time. All right, this is data which shows a Pacific decadal oscillation. Sea surface temperature, which is plotted here. Again, this is an average, and these shifts are in degrees centigrade. Sea surface temperature changes due to Pacific decadal oscillation. When it's hot, that's of course represented by the red, and so one has the state of the sea surface in the Pacific is warm, then it will flip. They use the words flip. It can flip and all of a sudden become cold, and then it will flip and become warm again. And what's instructive here is if you notice when this occurred, it occurred right around 1940. 1940, and when did it cut off? About the late 1970s. This is the warming, this is the cooling period that I've shown you before, and it seems to be remarkably coincident in time with the warming which occurred later and the warming which was going on before 1940. This is the other chart I'll show you, and it's similar, but it has more data. I apologize for this. I couldn't find this figure independent of this, so forget those big spots up there. But what we're plotting here is sea surface temperature as a function of years. Here's a temperature rise recently, and that's when the Pacific decadal oscillation is positive. This is when it was negative, as I just showed you. It's different data, but it's 1940 to 1980. The PDO was positive in this time, and note the temperature is rising then, and it was negative here. This is a remarkable correlation between temperature that you can measure and something that's going on in the sea. And so this looks to be a very strong indicator of that the changes in the flow patterns of the ocean are going to affect atmospheric temperatures. So that's one of the possibilities. The second is sunspots, and this is really quite interesting. In the early 1800s, there was an astronomer named Herschel. He discovered the planet Uranus. He observed that the price of wheat was low, meaning the weather was warm and good for growing wheat, when there were sunspots. Yeah, that to me is a very unusual observation. I think if I was a scientist studying the atmosphere, I would never figure that out. But that was what he observed, and he published this in Nature in 1801. And so that has stood the test of time, and here's a chart which illustrates the kind of things Herschel was seeing. This is a plot of sunspots, the number of sunspots. It's an average sunspot number as a function of years. Here we are here, 2000, and this is 1600. This is the Ice Age. There's something called the Maunder Minimum. There were no sunspots here for over 60 years. No sunspots. Then they developed and they dropped again. And so there's a real connection between the fact that these sunspots, when there are none, it's colder, or when they decrease, it gets colder. And this correlates fairly well with temperature. Note that the sunspots are dropping here. They have been high, as Dean mentioned, but they're going down, and that's leading us to colder temperatures. This is a plot of, as Dean was talking about, the correlation between cosmic rays and clouds. This is when cosmic rays come in, and they're affected by the sun's magnetic field. They cause clouds, and if the cosmic ray, if they get smaller, if they decrease, they're going down, then in fact the cloud cover goes down. If you don't have as many cosmic rays, you don't make as many particles to cause water vapor to condense on, and you get fewer clouds. And so this is a process by which we are affecting the temperature of the Earth. And this time doesn't permit to go into the kind of detail about that.
Martin, you want to wrap it up?
Okay. All right, this is the last chart on temperature and sunspots. I've shown that before, so this just shows how well correlated that is. Okay, let's see. Do I get, I would like to respond to Dean with 3 charts. Can I do that? I've got a neat way to do this.
Sure, it's all right with Dean. It's all right with me. Okay with you?
Uh-oh. This computer, oh wait. Okay. Dean said that the medieval warming period didn't exist, okay? This is a plot from the IPCC organization, okay? This is his favorite organization, and it is data from them, and they show a medieval warming period and a little ice age, okay? So the IPCC has admitted to the fact that it was. All right, one more. Dean has mentioned tipping points. This is a very, I'm sorry, it's a busy curve. This is millions of years, all right? This is really the last 10% of the age of the Earth. The Earth is billions of years old, okay? But this is millions, and here we are here. CO2 is 20 times higher here during all this time. Let's say we are way down here in CO2. CO2 has been higher. The temperature has been hotter. This temperature is 22 degrees centigrade. So it's 7 degrees centigrade hotter. The CO2 is 20 times as much, and there's been no tipping point. So you don't have to worry about that. We're not close to that at all. The other thing about, Dean showed computer estimates. These are computer models. This is a plot of temperature over the past, going back to 1800 and up to here. It's rising at about 0.5 degree centigrade. This is what the IPC has projected, okay? Where we are right here, we're right that little point right there. And the temperature is dropping over, and no, I won't find that. Anyway, so that's just another one. Let me go to the final chart since I'm last. Okay, in conclusion, we conclude that there really is almost no correlation between changing temperature and man-caused CO2, thus proving that the dominant cause of the changing temperature is not CO2. The more significant and likely sources of heating and cooling include energy exchange between the ocean and the atmosphere, and indirect heating and cooling caused by changes in solar radiance, primarily the sunspots, that affect cloud cover and therefore temperature. Thank you. Thank you.
Thank you. Let's have a hand for both of our debaters here. You want to both stand up? You want to stay there and take questions there?
Yeah. Well, you can use Frank's. Can't you use Frank's? Oh, okay.
Both of you. You want to stand at the podium?
Okay, sure.
Yeah, both of you. Here's some of the questions. The first one is from Jackie. How do you respond to the atmospheric scientist Reed Bryson's statement that there's a lot of money to be made in this? You can't get grants unless you say, oh, global warming, yes, yes, carbon dioxide.
Who are you addressing that to?
Either one.
Well, there's obviously that statement is not scientific. It's just an aspersion, because how can you prove that ExxonMobil, when they have been fighting man-made global warming for a long time, they offered $10,000 to anybody who wrote an essay that could get published against man-made global warming. And they've spent about, as of 2 or 3 years ago, they spent $23 million in those damn things. Peabody Coal has been lobbying. So there's a lot of people out there that are spending money on the other side.
The next question, can we trust the U.S. instrumental temperature records of the weather stations in the United States for accurate data?
There are two kinds of measurements. There's surface temperature measurements and temperature measured with satellites. We've had satellites since 1979, and that's by far a better, more reliable way to make the measurements. The surface measurements are affected by what are called urban heat islands. You'll put a temperature sensor somewhere near an air conditioner, and so all of a sudden it's going to be a different temperature. So the surface temperatures are not very reliable, but the most reliable ones are the satellite measured temperatures.
This is from Diane.
Can I just add to
Oh,
that?
sure.
On the question too, I mean, the U.S. Sensor data does not include the rest of the world. So we're all talking about global temperatures and global influence. CO2, if it gets in the air in a year, it's circled all around the globe. So the U.S. is only a part of the issue.
I get one quick
Sure.
rejoinder. Russia stopped recording a lot of the temperatures in the last 20 years. And so a lot of the global warming records don't show the fact that there was a lot of data which wasn't reported and taken in Russia. And so that's tended to raise the temperatures.
Okay, if this is from Diane Sandquist, if the Earth is in a cooling phase, and yet temperature data shows it is warmer, doesn't that mean the people are causing it?
No, it's just a simple fluctuation in one of these mechanisms that drives the process. I showed you that this big blue chart with all the big wiggles on it. We're just in the average temperature zone. If temperature is cooling off, that doesn't mean humans are doing it. It's simply either the oceans or sunspots or something like that.
I'd like to add that you notice in his rejoinder, he agreed that the world was warming, and yet in his pitch he says we've been getting cooler recently. So we got to be consistent. And
Dean, that's a 10-year recent event, okay, but which is not predicted by anybody's computer codes. It's natural variability. It's not predicted by the billions that we spent on computer codes. They didn't predict the ice age. They didn't predict the fall in temperature between 1940 and 75. You know, that's a lot. $1 billion is a lot of money. At least to Republicans.
This is from Jim Knapp. How does nature create ocean flow patterns? Do we know?
you're the one.
I'm not quite sure I know, but I think it has to do with the density of salt water. As it gets warm, that changes it changes the density, and it causes it to sink, and one has those kinds of things which drive it, but I'm no expert on it.
Well, I'm not an expert either, but you can't duck the question of causality by saying it's something else that you don't know the cause of. You know, I mean, that's what he's doing when he says it's ocean warming. Now, my understanding is that the oscillations that he talked about, and there's also an Atlantic one and a southern one, are bringing hot water from the tropics, which gets a lot more sun, and therefore the ocean warms more. It takes hot water and goes it north, and the heat above that stops the cold air in the winter from going too far, so that you get a cold front and a hot front meeting, and usually it's, you know, in the temperate attitude. Recently, the cold air has beat out the warm air.
Okay, this is from Joe Levy, why has the issue of global warming and man's contribution become a political issue? Republicans and conservatives say that there is no global warming caused by man, while the Democrats and liberals believe that man is either causing or contributing to it.
Well,
We don't discuss politics at the club here, do we?
Well, that's a soft question to me, but in my conviction is that conservatives generally don't want big government or lots of government spending. And if there is something so bad as global warming, the only way to cure it is those things. And therefore, they're fighting tooth and nail to make it not feasible.
I just comment that all this got started about 40 to 50 years ago. I think the activists in Europe were looking for a new cause. The wall fell, and sure enough, environmentalism seemed to be great, and the notion of global warming came up, and off we went on a run, on a tear like that.
When you mentioned Europe, isn't there the Greens that they refer to? I remember being in Italy, in Venice, and there were these boats going by with them in green shirts, and they were going to a rally. Now, I don't know where they could go to a rally in Venice with all the water, but that's where they were going. This is from Dr. Remy. Alarmists say that when the weather is hot, that it is due to global warming, but when it is cold, as we have recently experienced, they say it is climate change. Is this not disingenuous?
Dean?
Well, I don't think there is a big difference between the word climate and the word weather. I mean, if somebody can tell me, I think generally, though, the people think of climate as a larger study, and weather is what happens tomorrow. But in a sense, they're both the same.
Regardless of what is causing global warming, isn't it important that we clean up our air with better automobiles, better use of wind and nuclear, just in general, greening of our country?
I'd say sure, so long as we can afford it.
Well, yes, and if you think of the long term, I mean, when you're thinking climate, you're thinking long term, not these little variabilities that we talked about. And when you think of oil, there's a lot of there are some claims that we have peaked out in the production of oil on this earth, and we're going to get oil is going to keep raising in price and getting lower. So we need to, in the long term, do something about oil. Coal provides about 36%, I think, is the number of the CO2 that hits us in the air. And a lot of countries have coal. So as oil goes down, we're going to probably be burning more coal. So pollution is an issue, as well as global warming.
Let me just say, the poor countries of the world need low-cost fuel to develop their economy, and it's important that they be able to do that. Yes, we should work for alternative sources, but I don't think we should go to the extent that we're planning to go to throttle our industry and affect the CO2 generation, because it really isn't changing effect in the atmosphere. In terms of cleaner cars and engines and all that, so air pollution is actually pretty good. I don't really find it all that bad. Maybe I think Tokyo is even pretty good now.
Have you been to Cleveland recently?
Are the rivers still burning up there?
This is from Dr. Remy. Boy, you've been doing homework here. The U.S. National Snow and Ice Data Center in Colorado found that Arctic summer sea ice has increased by 409,000 square miles, or 26% since 2007. This appears to challenge the cherished belief of those who claim that the North Pole will be free of ice by the summer of 2013. What do you say to this?
I haven't seen that data, and it contradicts the data that I have seen. As I said, I think this year some news has come out that the winter ice is covering more of the Arctic that had been bared in prior years, but it's again skim ice. So I guess the real answer is we'll just have to wait and see. But my conviction is all the countries in the north are prospecting up there, and they expect ice-free, at least in the summer. And there will be a Northwest Passage. In fact, that ships have already taken that route. From where? Where was the data from? Oh, from Colorado, that data. Well, I haven't seen it, and I bet you it has something to do with the area that's covered by the skim ice has increased because it's been colder, I think, than the last few years up there. But I don't know.
This has nothing to do with CO2. This has to do with just a simple and natural processes of the Earth doing its thing, warming and cooling to whatever reason. It has nothing to do with CO2. The fact that the ice is melting, well, all right. But it's going to come back again because if we live long enough to see that. But anyhow, so it has nothing to do with CO2.
Gladys asks, describe weather versus climate. Long-term versus short-term. You did that? All right. When Phil Jones, boy, these are great questions. When Phil Jones from the University of East India, Anglia, okay, emailed Michael Moore that he was going to spike studies that cast doubt on the relationship between human activities and global warming. Should that raise a red flag on the truth of global warming? You know who that came from, don't you?
Yeah, now East Anglia is in England, and it teams with the Hadley Centre, which is an agency of the UK Meteorological Society. So somebody said that the Hadley Centre was the origin of this big furor about the emails that were hacked. I don't think that's true. There probably are a lot of trading between the two organizations because they're geographically close, and they team on a lot of things. Like, for instance, on their model of the global model, East Anglia produced the land data, and the Hadley Centre produced the ocean data, and they merged them. Now, I've read a little bit about that furor, and the deniers of global warming have been, I was going to say vicious, but let's just say aggressive. This hacking business is just a part of it. They have appealed to the Free Information Act. What is that called? The Freedom of Information Act for letters and for everything in this country. And they've hacked this mail, and tempers have risen. This guy, Mann, who did this, is the director of the climate organization of Penn State University. He's a very reputable scientist, and he was involved when he was also quoted as saying he was going to trick something, and what he was trying to do was merge the tree boring data, tree ring data, with ice boring data. And at the merger of those two data, how do you, it's a terrible problem. How do you make it global? How do you believe in it? So it is a big problem, and he was frustrated by everything. That's all I can give to that.
Okay. I need help on this question. It says the effect of...
Can I comment just
sure.
briefly?
Sorry, yeah.
Well, first of all, Mann is being investigated. I just learned that somebody saw him on TV tonight. Penn State is investigating his role in all these emails. Dean, it wasn't the U.S. people who were doing the hacking. We don't know who it was. It could have been employees there who realized that they were telling fibs. okay, and they released it. And Jones and Mann have both been at the heart of suppressing this information. What were they suppressing? They were suppressing the fact that the Earth is cooling. That was inconsistent with their models. All right, so that's what they were trying to suppress.
I need help with this question. It says effect of blank in the oceans and global warming. Effect of the effect of the atomic bomb test in the ocean and global warming.
Well, you were there.
Yes, that's a perfect question for him.
Well, I'll just say as an aside, the second bomb at Bikini was suspended 89 feet into the underwater from a landing ship craft. And when it exploded, a column of water really towered up with a big wave that covered all these ships. But that tower of water was the most beautiful thing I've ever seen, because there was this hot core that was radiating, and as it came out to the surface, it was colored. It was a rainbow of light. And the pictures have all been black and white of that, but it was a fantastic. So there was at the time some heating, but obviously there have not been, thank goodness, enough atom bombs dropped. And I think that was the only one dropped in the water that I know of.
You mentioned the coloration of the water. When I saw the Hubbard Glacier, pieces were breaking off and they were blue. It wasn't white. What causes that blueness in the ice?
Your turn.
All right, anybody out there?
Well, if you look,
Sorry, I asked the question.
if you put light through a prism, you get a rainbow, because the light, different frequencies of light will separate in the prism, and you get different colors. And this somehow that piece of ice was hitting off the blue. Was
Okay.
pushing off the blue.
Sorry, I threw your curve, guys. You were doing so well. Let's give our debaters a round of applause. I think it was a great debate. We have a calendar events somewhere showing our different events that Sharon developed, and included is the February debate, which will be on healthcare. Now what? We will have the various healthcare providers, hospitals, doctors, insurance companies debating their role in our healthcare system, whatever it turns out to be. Sharon, did you want to say a few words?
Let me get in something. I have copies of my charts. Anybody would like them? I have a copy, printed copy here up on the table.
Thank you. Thank you to Dean and Martin and Frank for being the moderator. Thank you for everyone that attended. This was the first in a series of what we're calling membership debates. It's put on by the membership committee. Lou Korahai was the originator of this idea. He said we should have a debate here. Unfortunately, Lou had bypass surgery yesterday, and Frank filled in for him. He's doing okay, according to his wife. And Frank filled in and did a great job. This idea of the debate came from our committee's interest in finding out what the membership wants. So anybody who has an idea, just call me or email me and just let me know, and we'll work it into some kind of program.
Thank you, Sharon. You know, it's so nice to see some new guests here, but it's also nice to see our regular club members coming to an evening event. Isn't it nice to get out in the evening? Of course, Bill, you're alone. Your wife isn't here, so thank you all for coming.